In this video, we're going to talk about multi-head latent attention introduced in DeepSeek. We'll talk about how it works and how it managed to reduce KV cache size without impacting on the model quality. If you want to learn about simpler attention variants like multi-head attention, multi-query or group query attention, please see my other video. It also describes why KV cache size is important for long context length. Let's go. In standard attention, we start with three projection matrices: W-query, W-key, and W-value. The token embedding is multiplied by these matrices to produce the query, key, and value vectors. These are then used to compute attention and ultimately predict the next token. The longer context and the more heads we have, the more key and value matrices to save in memory. Multi-head latent attention approaches this differently. It also begins with three but slightly different matrices: WDQ, WKR, and WDKV, but these produce down-projected latent vectors. In other words, the activations are smaller than the original token embeddings. Now let's focus on the right side of the diagram. Instead of traditional KV cache, we store a compact representation called CKV. Because it's down-projected, it takes significantly less memory. However, before we can use it in attention, we need to apply some transformations. Two up-projection matrices are used for that purpose. One reconstructs the value and the other key matrices. In standard attention, both query and key are rotated using rope to encode token positions. In multi-head latent attention, the key is built from two parts. One component is generated without positional rotation, called K-nope. The second component, K-rope, comes from rotating the latent key representation. These two pieces are then combined to form the final key matrix used in attention. The query is constructed in a similar way. First, we produce a latent vector CQ, which is split into two components. One that receives the rope rotation, and the other that doesn't. After combining them, we obtain the final query matrix. The key idea is that instead of storing the full key and value matrices in the cache, we only store CKV and K-rope, which are much smaller because they come from the down-projected latent space. We don't need to cache query, since it's generated fresh for every token during decoding. However, this more complex design enables another optimization, called absorption. If you look at the full attention computation, it normally requires many matrix multiplications. DeepSeek reduces this cost by absorbing the up-projection matrices WUK and WUV into other matrices ahead of time, which eliminates several operations during inference. Do you also think this design is genius? Let me know in the comments.